This is SpaceTime, Series 28, Episode 81, for broadcast on the 7th of July, 2025. Coming up on SpaceTime, a new interstellar object discovered flying through our solar system. Could China beat America in bringing back samples from Mars? And the new Vera Rubin Observatory drops its first stunning astro images. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered what appears to be a new interstellar object travelling through our solar system. The comet was identified by NASA's ATLAS Asteroid Terrestrial Impact Last Alert System Survey Telescope, which is located in Chile. The object, which has been designated 3I Atlas, originated from the direction of the constellation Sagittarius. It's currently located about 670 million kilometres away. Now, since those first reports a few days ago, astronomers have looked back at observations from the same part of the sky, both using the ATLAS telescopes around the world, as well as the Zwicky transient facility at the Mount Palomar Observatory in San Diego. These so-called pre-discovery observations date back to June the 14th. Of course, numerous telescopes have reported additional observations since the comet was first reported. So what do we know? Well, we can tell you the comet poses no threat to Earth. In fact, it'll pass no closer than 240 million kilometres from our planet. 3I Atlas should remain visible in ground-based telescopes through to at least September. After that, it'll pass too close to the Sun to be observed. It'll actually make perihelion, its closest approach to the Sun, around October the 30th, when it will be about 210 million kilometres away from our local star. That's roughly just inside the orbit of Mars. It's expected to reappear on the other side of the Sun by early December, allowing for renewed observations. Now, at the time of this broadcast, 3I Atlas's size and physical properties are still being investigated. Astronomers can identify an object as originating from beyond our solar system both by its hyperbolic trajectory and its velocity. The velocity has to be greater than the minimum value needed to escape our solar system, which at Earth distance is 42 kilometres per second. 3I Atlas is currently travelling at more than 51 kilometres per second. It's only the third confirmed interstellar visitor detected passing through our solar system. Of course, the first was the asteroid Oumuamua back in 2017. It was detected when it was about 33 million kilometres away from the Earth and already heading out of the solar system. It was characterised by its unusual flat disc-like shape, reddish colour, hyperbolic trajectory through the solar system, and unexpected acceleration away from the Sun, thought to be due to the release of volatile gases. While Oumuamua's exact composition and origin remain a mystery, scientists have proposed various theories, including that it might well have been a comet with an unusual chemical makeup, or more likely a chunk that's broken off a larger object which was rich in nitrogen ices. Oumuamua came into the solar system roughly from the direction of Vega in the constellation Lyra, and its outward trajectory headed towards the constellation Pegasus. The second reported interstellar object was the comet 2I Borisov, which, unlike Oumuamua, appeared to look a lot more like a familiar natural comet, complete with a gaseous coma and a streaming tail. It was first identified in 2019. Also, unlike Oumuamua, Borisov was first spotted on its inbound journey, allowing astronomers to spend more time studying it. They discovered it had an extremely hyperbolic orbital eccentricity, passing close to the Earth on December the 28th, 2019, at a distance of about 2.8 million kilometres. Borisov entered the solar system from the direction of the constellation Cassiopeia, near the border with Perseus. Now, this direction indicates that it originated from the galactic plane, rather than the galactic halo, and it left the solar system in the direction of Telescopium. As for 3I Atlas, there's a lot more to learn, and we'll keep you informed. This is SpaceTime. Still to come, could China beat America in bringing the first samples back from Mars? And the new Vera Rubin Observatory drops its first stunning images. All that and more still to come on SpaceTime. There's growing speculation that China might well beat efforts by America and Europe to bring the first samples from the red planet Mars back to Earth. Now, if successful, this would rocket Beijing to the top of the latest space race, cementing the communist nation as a world leader in engineering and scientific research. Recently, Beijing officially announced its Mars sample return mission project, Tianwen-3, marking a significant step forward in Chinese planetary exploration. The mission aims to bring Martian samples back to Earth, where advanced laboratory instruments can be employed to conduct comprehensive analyses, seeking to determine whether life ever existed or may still exist on the red planet. The sample return mission represents the next research goal for Beijing, following its successful deployment of the Zhurong rover on Mars back in 2021 and numerous missions to the Moon, including sample returns. The thing is, right now, planet Earth is the only place we know in the entire universe that harbours life. Current research traces the origins of life back to approximately 3.8 billion years ago. That's roughly 700 million years after the formation of the Earth and the solar system. Scientists believe it was Earth's early evolution during its first 700 million years of existence which provided the setting that allowed life to develop here. However, definitive evidence is still lacking as to whether life on Earth arose solely through indigenous evolution or whether panspermia had a play. In other words, it started somewhere else and came here in meteorites. The thing is, like Earth, Mars lies within the Sun's habitable zone. That's the Goldilocks region around a star where temperatures are not too hot, not too cold, but just right for liquid water, essential for life as we know it, to pool on a planet's surface. And of course, there's plenty of evidence now that Mars once also had a warm, wet, dense atmosphere capable of supporting life, at least early in its history. In fact, from an astrobiological perspective, the early Martian environment would have been conducive to the survival of many so-called extremophiles which are currently found on Earth. The key in China's Mars sample return mission will lie in identifying Martian materials most likely to preserve evidence of past or present Martian life. Now, to achieve this, scientists will need to conduct extensive research to work out where on Mars is the best place to go looking for life. This will include regions of Mars where liquid water was likely to be present in the planet's early history, as well as areas rich in essential metallic nutrients and sites where traces of Martian microbiological activity could potentially be preserved for billions of years. Beijing says China's Mars sample return mission will launch in 2028, and like the proposed NASA ESA mission, it'll use two separate rockets. The first will include a lander which will land on the red planet's surface to collect samples, and also carry an ascent stage which will launch from the lander back up into Martian orbit, transporting the samples with it. The second rocket will be the Mars orbiter, which will wait in orbit around the red planet to receive the samples being brought back to it from the Martian surface. The lander will need to drill about 2 meters into the ground. That's a critical depth because the surface of Mars has been bombarded by radiation for billions of years. That's resulted in corrosive chemicals that could destroy any signs of past or present life. But deep below this hostile surface layer, valuable organic materials may still be preserved. Those samples will be collected, flown back up into orbit, transferred to the orbiter, and then flown back to Earth for detailed analysis. Now, if successful, China would be poised to become the first country in the world to return potentially biologically active planetary material, including potential life forms from beyond Earth. The potential risks such substances might pose to Earth life, including humans, is of course a major concern. Now, to address this problem, China plans to construct a specialised facility where Martian samples will undergo comprehensive biochemical and pathological testing under strict isolation from Earth's environment. Let's just hope the isolation facility that Beijing build is a lot better than the Wuhan Institute of Virology. This is SpaceTime. Still to come, the new Vera Rubin Observatory drops its first stunning images, and later in the science report, the queen of flavours, vanilla, could be under threat due to climate change. All that and more still to come on SpaceTime. Astronomers have been astounded by the stunning first images delivered by the new Vera Rubin Observatory in Chile. Built by the National Science Foundation and the United States Department of Energy, the 8.4-metre optical telescope is equipped with a massive 3,200 megapixel digital camera designed to provide an ultra-wide field view of the heavens. Rubin will undertake the world's largest sky survey, repeatedly observing the entire southern hemisphere over 10 years. Known as the Legacy Survey of Space and Time, it'll provide unprecedented insights into the dynamic universe, tracking everything from asteroids and supernova explosions through to the movement of distant galaxies and the mysteries of dark matter and dark energy. To do this, Rubin will generate 20 terabytes of new data every night, an astronomical ultra-high-definition treasure trove for scientists to study. And this global scientific endeavour includes Australian astronomers and data engineers. Australian Astronomical Optics at Macquarie University has partnered with Swinburne and Curtin universities to help process and store the data deluge that Rubin will be providing. In fact, they'll host and process more than 7 petabytes of data from the observatory every year. Head of Research Data and Software at Australian Astronomical Optics, astronomer Simon O'Toole, says it's a huge volume of material. O'Toole says that as the next generation of large telescopes and surveys comes online, the challenge will be to get all this data out to astronomers to do their analysis. And he says that requires a game-changing software platform to manage and deliver the enormous data flow.
So basically, the goal of this telescope is to map a lot of the structure and the detail of the universe, both the near universe, so within our solar system even, and the extremely distant universe. To do that, it's observing the entire southern sky in 6 colours, 6 filters every 3 nights. And then it will do that every 3 nights for 10 years. When we add all of those images together, then we get an incredibly deep image. It's like taking an incredibly long exposure with your camera. You get a lot more information. And that's why, we need to understand the images and need to remove some of the artifacts and even the brightest stars to see some of the really, really faint sources and faint structures that there. But then there's also the time domain aspect as well, and that's where we'll see a lot of asteroids.
Well, you spotted a whole bunch of asteroids just in the first few hours of observation.
That's right. So I think it was around about 2,000 asteroids discovered in the first 10 hours of observation, which is amazing because that's approximately the number of asteroids that are discovered every year by all of the telescopes on Earth. So quite a remarkable feat. And this was in some ways anticipated. It's one of the reasons for doing this survey, right, is that we want to be able to observe the entire sky. And if we do that, we're going to see things that are moving at quite a fast pace. And so I can see a lot more asteroids coming because there'll be things that are further away, of course, move more slowly. So we're talking asteroids. I perhaps naively hope that if there is this Planet 9 out there, we might see that, but not going to commit to anything there.
Well, at least you know where to look for Planet 9 now. That's that.
Exactly. Exactly.
Knowing where that gravity well is an important feature. With these asteroids, some of them are Neos. That's a bit frightening.
Yeah, it is. Although I think they're pretty small. I think the Neos that are the most frightening are the ones that are large and could cause some serious chaos on Earth. And I can't remember the B612 project. I think they published, I can't remember the exact numbers, but it's around about 96% of the large sort of Earth killer asteroids are known. And then certainly we would hope that Vera Rubin might mop up the rest, find the remaining few percent of these asteroids. And so we're going to have a better understanding and also map out their trajectory, their path. Because that's the thing when you hear a news story about asteroids that may hit Earth, it's always based on the current understanding of how it's moving through space, it's a 1 in 200 chance of colliding with Earth at some distant date 10 years in the future. They take a little bit more data and then that goes from 1 in 200 to 1 in 2 million or something like that. And so Vera Rubin is going to be observing for 10 years at least. That's the main survey. And so I think that it will map out a lot of those sorts of near-Earth objects.
This is a very different type of observatory to other optical observatories, isn't it?
It is. And so it's an extremely large field of view. I think it's 13 square degrees per image. It's a 3.2 gigapixel camera. It's the largest camera ever built, and it's very, very fast. So it's an 8-meter telescope, so it's the largest imaging survey telescope ever, and it can correct for some of the Earth's atmosphere's distortion, the twinkling of the stars, and it's dedicated to this one task, to just mapping the sky every night for 10 years. and no other telescope has ever been built quite like it.
With a 10-year observation period, you're going to be able to watch the universe evolve in that time, not by much, but by something. That's got to bring the question of dark energy into it all.
Absolutely. And so because the telescope is equipped with 6 different coloured filters, they can basically determine the redshift. So effectively, it's related to the speed that a galaxy is moving away from us and the proxy for its distance. They can measure the redshifts of many, many hundreds of millions and billions of galaxies. And so that will put some very tight constraints on our understanding of dark energy, and the models that are currently out there will almost certainly be put to the test. There will also be a lot of other what we call transient phenomena, and so not just the near-Earth asteroids, but a lot of things that go bang. We'll see gravitational wave events, we'll see supernovae, I'm sure we'll be looking for the optical counterparts to these fast radio bursts. There'll be a lot of transient phenomena that LSST data will uncover, and that's a huge component of the research that's going to be undertaken as well. Many of these events give us an understanding of more fundamental properties of the universe as well.
As part of the final commissioning stages, an image has been taken that was revealed this week. Tell me about the image.
So it's of the Virgo cluster, which is a large... You can think of it as a group of galaxies, but in astronomical terms, it's known as a cluster. The galaxies are gravitationally connected or bound, and it's a very, very famous cluster. It's in the constellation of Virgo. But the image itself, it's one of those things that if you think of the Hubble Deep Field image or the James Webb Deep Field image, these sorts of things where they've stared at a patch of sky for a very long time, that was a very tiny patch of sky that was apparently blank. This is just an enormous field of view. We knew a lot about the Virgo cluster because it's very well studied. It's quite nearby in the cosmic scheme of things. We're in our own little smaller group of galaxies with Andromeda, with the Magellanic Cloud. There may be a handful of other smaller galaxies as well, but we're in a smaller group. We're called the local group. Yeah. That's right. So Virgo is the nearest. I think it may even be classed as a supercluster, in fact, because it is extremely large. There are many, many, many galaxies in the Virgo cluster, and so it's extremely well studied, and they still make many, many discoveries about it. And I imagine this image will produce some of those new discoveries just because it's multicolor, it's deep. Very few 8-meter telescopes out there do imaging at this scale for 10 hours. There are none that do it at this scale, but for 10 hours, you don't get a 10-hour observation of a patch of sky with an 8-meter telescope normally. So I think there'll be a lot of stuff to discover just about the Virgo cluster. So yeah, it's a phenomenal image. It's one of those images where I knew that it was going to be amazing, but when I saw it, it still blew me away. It was still even better than I expected.
What's it told you that you didn't know before?
That's a very good question. I'd say that the universe is more complex and more spectacular than I had realized before. And I've been working in astronomy for over 25 years, and it still takes my breath away. And you know, the capacity, the universe still has the capacity to do that. That's just incredible.
That's Dr. Simon O'Toole from Australian Astronomical Optics at Macquarie University. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Vanilla, known to some as the queen of all flavours, I'm assuming chocolate's the king, could be under threat due to climate change. A report in the journal Frontiers in Plant Science has found that climate change is driving the insects that pollinate vanilla away from the wild vanilla plants. The authors model the habitat distribution and overlap of 11 vanilla species and 7 of their pollinators, and they then checked on them under different climate change scenarios. They found that while some of the vanilla species might thrive in future climate change scenarios, the pollinators would not. In fact, the authors found that the habitat suitability of all their pollinators would decline under all future climate change scenarios, risking the very existence of the wild vanilla plant. It's been revealed that just days before the Iranian missile attack on Israel, scientists from the Weizmann Institute in Tel Aviv had developed a breakthrough blood test to detect leukemia. However, the Islamic Republic's missile attack destroyed the laboratory. A report in the journal Nature Medicine says that discovery may lead to an innovative blood test for detecting a person's risk of developing leukemia. This test would potentially replace the invasive diagnostic procedure of bone marrow sampling. However, decades of research were lost in seconds when the Iranian Islamic Revolutionary Guard's missile slammed into the building. The hit destroyed some 45 laboratories, some containing scientists' entire life's research. And that will take years and millions of dollars to replace. A new study has found that cheese can give you nightmares. A report in the journal Frontiers in Psychology has shown a link between the popular dairy product and bad dreams. Scientists investigated links between diet, sleep problems, and cultural beliefs about diet and sleep with an online survey of over 1,000 people. They found healthier eating habits seemed to be linked to a better sleep and a better recall of dreams, but that consuming dairy products was linked with nightmares. The authors think the nightmares might be due to lactose intolerance, causing overnight tummy upsets, which then affected people's sleep. There's a disturbing growing trend in many universities to offer degrees in fields which have no real value. These so-called rubbish degrees cover a range of fields, usually in the arts and humanities where they can't do much harm. But they're now being offered in some areas of science and medicine where they could prove to be dangerous, especially if people with these trashy degrees use them to try and practice real medicine and healing. Tim Mendham from Australian Skeptics says the latest is what's termed a Bachelor of Health Science degree, which sounds very professional, but actually includes pseudosciences like homeopathy, flower essences, and iridology.
Naturopathy is a mixture of common sense, health, diet, exercise, and then throwing in a lot of other things as well. A lot of pseudoscience, concepts of vitalism, which is energies and community and electricity flowing through the body, and it drags in, moves into all sorts of other areas, pseudo-health ideas such as homeopathy and flower essences and iridology and that sort of stuff. So even though it starts off with something that looks half reasonable, it actually develops into very, very weird areas, and certainly the underpinnings of it are not particularly scientific. So it's a health regimen which is sold to people, nice friendly people selling herbal essences and this sort of stuff, but the whole basis of it is not very scientific.
So common sense things combined with a little bit of unicorn dust.
Probably a little bit of common sense and a lot of unicorn dust. You have to get your amounts right. The trouble is that if it has a prestige, well, there's a market for it, okay? There's obviously, the naturopaths are around and little storefronts and that sort of thing. What's happening is that because there's a market for it, there is actually a degree in naturopathy. God knows where and how useful they are, but there are degrees that people can take, which they claim that gives them medical background as well as naturopathic information.
It's a respectable sounding degree, a Bachelor in Health Science. That sounds really respectable.
Well, there are all sorts of things here. Bachelor of Health Science in naturopathy.
Yeah, but you say the last bit under your breath.
Yeah, it's like a doctor of chiropractic. So there's a university degree course in naturopathy, the Bachelor of Health Science, and it covers, quote, evidence-based practice. That's arguable. And you have electives in applied homeopathy, and homeopathy is junk. Okay, it is one thing the skeptics can say 100%. Homeopathy is junk. Homeopathic foundations, ain't a lot of those. Flower essences, which is sort of magical thinking about flowers, I said. Iridology, which is also junk. That's looking in the iris and the eye and seeing your health conditions, etc., based on the colours and the shapes. And they add that this stuff will also help people harness the healing power of their own bodies. And that's basically the premise, a lot of naturopathy in these things, that the body will heal itself. Not always so, as we know. It can do with a bit of help, and over the years, decades, centuries, medicine has developed helps for people who have certain conditions, and they get better thanks to that help. Asking the body to heal itself, you're sort of throwing it back about 1,000 years or so, probably even longer. So therefore, there's this course which is offering, it's an occupational course. It's a professional, in quotes, training, vocational course. It's not a research academic university as you would normally see it. It's basically saying it's a technical course that will help you set yourself up as a naturopath. It's a shame it's a university. They'll call themselves a university.
Well, let's not forget the famous Wollongong University's doctorate scheme.
Yes, Wollongong University gave someone a PhD in anti-vax. That was couched as sort of WHO and government policy on vaccination, but it was actually written by someone who's rabidly, I suppose, anti-vaccination, and that's what the PhD was. It was a highly criticised PhD. People said it was not very good quality, full of errors, but the Wollongong University issued it anyway and did not like the idea of it's being suggested to be withdrawn, which it can be withdrawn if you find that the stuff they've written is rubbish. Some very, very dodgy practices. And the answer would be, why are you offering these courses? And because they say people want them. In other words, there's a buck to be made for the universities. But yes, it's a problem that offering sort of courses in junk science, and the skeptics have looked at this in depth and went through. There was hardly a university in Australia that was not having some sort of course in a pseudoscientific area, often in medicine, but in other areas as well.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.